Welcome students. In this video, we'll be solving some numericals which are actually containing dependent sources. So just to have some recap, what are dependent sources? We have read that the energy sources are of two types. One we call as an independent energy source and the other one is the dependent energy source. And how do you recognize it in the circuit is simply with the symbol. If we are having a symbol like a circle, it is an independent energy source. Now that can be a voltage source or that can be a current source. So it is represented with a circle. And the dependent sources are like this. We call it as a diamond shape. Now again, it can be a voltage source or it can be a current source. Then further you must be knowing that this dependent voltage source can further be, it can be dependent on the voltage or it can be dependent on the current. Similarly, if we are having a current source which is dependent, it can be again dependent on the voltage or the current. So we are having four different types of dependent sources. Now today we'll be solving some numericals which will be having a mix of dependent and independent sources. Like suppose the first question we'll be solving, we have to find the node voltage Vx. So if you see the diagram, Vx is the voltage given across 20 ohm. So it means this particular node is having a voltage of Vx. And we all know that it is a single node. There is no drop occurring in this particular line. So we can say this node is also same. So the potential is actually same here. So we have to find this Vx and we have to use nodal analysis. So the fact that whatever steps we have understood regarding the nodal analysis, the steps are going to remain same. It doesn't matter like if we are having an addition of dependent source. So first of all, you should be able to recognize this particular source is a current source, but it is an independent current source. Means it will be able to supply this 2 ampere irrespective of whatever is happening in the other resistors. And this one we call as a dependent voltage source. Sorry, it is a dependent current source actually. It's a current source, but it is dependent on the voltage. Okay, so we call it as voltage controlled current source. It is voltage controlled current source. It's a current source as given in the symbol, but it is dependent on the voltage of Vx. So it means if suppose we are changing this value of R from 20 to some other value, then obviously Vx will also change. So the current that is being supplied by this source will also be changing. So that's why it is voltage controlled current source. It is not independent. Now regarding the analysis, there will not be any change. So as we have already discussed in our previous videos also, what are the steps regarding the nodal analysis, same steps we need to follow. So just to recall, what are the steps? The first step is we will be assuming current directions. We'll be assuming current directions. So if we see this current direction and this current direction, it is already given. But for these two resistors, I don't know the current direction. So you can assume it as anything. Then the second step is we have to apply KCL at a node. And the third step is we'll be using Ohm's law and we'll be converting that current into V by R form. And finally, we'll be solving our equation. So let us use all these steps here. So the first step already I have applied. You can see that I have assumed the current direction already. Now next step is we have to apply the KCL. So you can see here at node X, I will say, we can say that currents which are entering is equal to currents that are leaving, correct? Is equal to currents that are leaving. So what are the currents that are entering a node? You can see it is entering a node and others are all leaving, correct? So 2 ampere is equal to, we can write it as Vx by 10 because it is V by R form. Then we can write Vx by 20 and this current we can write as 0.2 Vx. So if you want to have a clear picture on this, you can see that this is a single node actually. This is a single node. So if you want to redraw actually your diagram, you could have drawn this diagram between two nodes. So all the sources are like this. So this is a current source. Then we are having certain resistors, and we are having this current source also. So you can get a clear picture over here that it is a single node, and the fact that this current is entering towards the node, and while as other currents as per my current direction, they are leaving. So this is what I have written. Now we are done with the equation, and you can see there is only, you can say, one unknown over here. So we can now proceed by solving this equation. So we can write Vx can be taken as common. It will be 1 by 10 plus 1 by 20. So 0.2 I can also write as 2 by 10. So Vx becomes, we can take 20 LCM from here. So it will be how much from these two terms. So we can write 2 plus 1 plus 4. So Vx would be how much? 2 into 20 upon 7. So that is 40 by 7 volts. So this is the voltage Vx value. Or if you want to write it in the fractions, you will get 5.714 volts. So this is the answer for this question. So what we have to realize that even if we are having a dependent source in our circuit, the analysis is not going to change as far as nodal analysis is concerned. We have to follow the same steps. You can create the equations, just solve them with your mathematics, and you will be getting the answer. So I hope this question was clear to you. Let us move on to the next question. Now again, you can see there's a circuit which is containing an independent voltage source, and it is containing a current controlled voltage source. Correct? It is a voltage source because there's a plus minus sign, and the fact that the shape is diamond one, so it is a, you can say, dependent voltage source, but it is controlled by I naught. I naught is the current in this particular branch. So it is being asked that we have to find I naught using mesh analysis. So again, there are already videos on mesh analysis. What are the steps? So just to revise, I will write here what are the steps that we have to follow. We have to first of all assume mesh currents, and that step is already actually given in the diagram. If you can see, there are three meshes over here, and the current is already being assumed as I1, I2, and I3. So the next step is we will be using that KVL equation in the different meshes, and we can then write that voltage into I into R form, and then we can solve the equation. So these are the steps that we need to actually use. So the first step is already being applied. And before we start the analysis, we have to understand that this I naught is in the same direction as this I3 is given. You can see I naught is also moving upwards, and the fact that I3 is also moving clockwise, it means the direction is same. So before starting the question, we can simply write I naught is same as I3 because the current direction of both of them are same, both are going upwards. So if we are able to find the value of I3, that actually is your I naught. And we can see there are three, you can say, meshes. So we have to form three equations. So we'll be writing equation one by one, and let us solve this question. So first of all, we'll be solving with mesh 1. So we can write for mesh 1. Now we will be applying KVL, and the rule for KVL is either you follow the sign convention, like if you are moving from plus to minus, that is minus, and if you are moving from minus to plus, that is plus. So this is one sign convention. If you are following the reverse of that, that is also true. The answer would be same. Or you can also write it in this way, that voltage rise is equal to voltage drop. So you can use any of the method. It doesn't matter. The answer should be same. So I'll be using this, you can see sign convention over here. So I can write plus 16, because we are moving from minus to plus, then minus 4 times. Now for this resistor of 4 ohm, there are two currents. So the current is I1 minus I3. Then minus 2 times. So if you see this resistor again, now there are two currents that are present here. So I1 minus I2. So I'll be revising this, how I am writing the equation. You have to see this loop. This is the first loop I am in. So we are moving from this voltage source. It is moving from minus to plus. So that's why it is plus, because I am following the sign convention. Minus to plus is going to be plus. Then what about the other two resistors? The fact that the current is moving in this way. So actually I can say this is actually plus, because current is moving in this direction, then this direction. So this is plus and this is minus. And this 4 ohm is the common resistance between this mesh and this mesh, that is I1 and I3. So both the currents are flowing, and the currents are in the opposite direction, because this current is moving in this way and I3 current is moving in the opposite way, as you can see here. So that's why it is in minus, and the reference is mesh number 1. So I am writing I1 minus I3 over here. Same goes for this one. You can see that I2 is moving this way clockwise, and here it is moving upwards. So this is moving downward, this is moving upwards. Again, they are in the opposite direction, and my reference is mesh number 1. So it is I1 minus I2. So I hope this is now clear to you. Now algebraic sum of all the voltages is equal to what? Is equal to 0. Now we can solve this equation. We can write 16, then 4 and 2 is 6I1, then it is 4I3, then it is minus and minus will make it plus, and here also it is plus, sorry, minus and minus makes it plus. 2I2 is equal to 0. Or we can write 16 is equal to 6I1 minus 2I2 minus 4I3. Or we can make it as simple again. We can divide it by 2. So we will get 8 equal to 3I1 minus I2 minus 2I3. So let this be my first equation. Now we have to move on to mesh number 2. So we will be using equation for mesh 2. So this is my mesh 2. And you can start with any of the resistor, it doesn't matter. So I will start from this 2 ohm resistor. So I will write 2 times I2 minus I1. Then I will write plus 8 times I2 minus I3 is equal to 10 I naught. So here I am using this concept that voltage rise is equal to the voltage drop. So if you see here, we are moving from plus to minus because this is the current direction. So plus to minus is what I call as drop. So these two are voltage drops. And here we are moving from minus to plus. This is what I call as voltage rise. So I have equated it that voltage drop is equal to voltage rise. And again, why I2 minus I1? Because this resistor is common between these two, you can say, meshes. And similarly, this 8 ohm is common between I2 and I3. So that's why. Now we can solve it further. Just you can say, write the next step, 2I2 minus 2I1 plus 8I2 minus 8I3 is equal to 10. But what is I naught? So as we have told you here, I naught is nothing but I3, correct? So if you will solve this, if you will be solving this equation, you should be getting, I will write it here. You should be getting second equation as 0 because it is I1, I2 and I3. There is no constant over here. So you should get 0 is equal to 2I1 minus 10I2 plus 18I3. Or you can again take 0. You can again take 2 common. So you might also get I1 minus 5I2 plus 9I3 is equal to 0. So this is the second equation for you. So we have derived equation from first, you can say, mesh, and we have also derived the equation from the second mesh. So there is again this third mesh left. So we will be continuing this question with third mesh. So this is the third mesh. Let us write for mesh 3. So we'll be taking now mesh number 3, and you can start with any of the resistor, that doesn't matter. So I can write 6I3 plus 8 times I3 minus I2 plus 4 times I3 minus I1 is equal to 0. So how I am writing this equation? Again, you are starting in this particular loop, correct? And we are moving from this 6 ohm. As I said, you can take any resistor first, that will not matter. And the current is moving this way, then this way, and then this way. And 8 ohm and 4 ohm, these are the resistors which are actually common between the meshes. Like this is the common between I3 and I2, and this 4 ohm is common between I3 and I1. And there is no voltage source, so this is equated to 0. So again, if you will solve it, you will get 0 is equal to minus 4I1 minus 8I2 plus 18I3. And again, you can take 2 common from them. So what you will get, 0 is equal to minus 2I1 minus 4I2 plus 9I3. So this is your equation number 3. Now see, we are having equation 1, equation 2 with us, and this is the equation number 3. Now if you will solve, if you will solve equation 1, 2 and 3, you should be able to get the answer. If you want me to solve it, then I can solve it with the Cramer's rule. So let me note down these all equations on a single page. So if you see the first equation, that was 8 is equal to 3I1 minus I2 minus 2I3. The second equation was 0 is equal to I1 minus 5I2 plus 9I3. And the third equation is 0 is equal to minus 2I1 minus 4I2 plus again 9I3. Now you know from the basics of your mathematics, if I want to know I1, I2 and I3, so according to the Cramer's rule, this will be delta 1 by delta, this will be delta 2 by delta, and this will be delta 3 by delta. So how do you find delta? Delta is found by the matrix of this 3 cross 3 matrix. So if I ask you what is delta, so you have to simply note down the coefficients of this particular right hand side. So you can write 3 minus 1 minus 2, then 1 minus 5, 9, then minus 2 minus 4 and 9. So if you will solve this with your mathematics, so what will be the result? It will be 3 times minus 45 plus 36. It's like if you are multiplying with 3, you will multiply these two and minus times the multiplication of these two. Then second term is minus, so it is already minus, so minus and minus will make it plus. Then 9 plus 18. Third term is positive, so minus 2 times minus 4 minus 10. So now if you will solve it, you will get, this is 9 into 3, 27, but this is minus. This is again 27, and this is minus 14 into minus 2, so that is plus 28. So these two terms will go, so the delta value would be equal to how much? 28. So we are done with the delta of all three. Now we need to find delta 1, delta 2 and delta 3. So what is the concept of finding delta 1, delta 2 and delta 3? If you are finding delta 1, then this particular column has to be replaced with the left hand side. So what is the left hand side? 800. So if I am finding delta 1, just replace this column with 800. If you are finding delta 2, replace second column with 800. And if we are finding delta 3, you can replace this column with 800. So let me find delta 1, delta 2 and delta 3 in next page. So let us find delta 1 first of all. So what I said, you have to replace first column with 800 and rest of the matrix has to be same. So minus 1, then minus 5, then minus 4, then minus 2 and 9 and 9. So you can see the values of these two columns are same, and this one has been replaced. This is going to give me my delta 1. So if you will solve it, it will be 8 times minus 45 plus 36, because this is the only multiplication that will happen, 9, 45 and 36. Rest of the terms would be 0. So if you solve this one, you will get how much? You will get minus 72. Similarly, if we find delta 2, for delta 2, we had to write in the second column A00. So this will be remaining same. And delta 1 is 3, 1 minus 2. That also should remain same. Now let us solve this. It will be elongated here only. So it will be minus 8 times 9 plus 18, because rest of the terms will be 0 actually. So if you will solve it, you will get minus 216. And if you see delta 3 means first column, second column will not change. So second column will also remain same, but third column will be replaced with A00. So again, if you are solving it, it will be solved up to this only, 8 only. So you will get 8 times minus 4 minus 10. So it is 8 into minus 14. So that is minus 112. And you see delta is already calculated. Then I have got delta 1, delta 2 and delta 3 values also. Now I should be able to find I1, I should be able to find I2, and I should be able to find I3. So what is I1? I1 is delta 1 upon delta. So it is minus 72 upon delta value, we can see it's 28. So it is minus 72 by 28. That gives you minus 18 by 7. Although we didn't have to find it, but it is a general question I am solving. So you can use it in the further questions actually. Otherwise we had to simply find I3, that is I0. So I2 is nothing but delta 2 by delta. So what is your delta 2? It is minus 216 upon delta is same actually for all. And again, if you'll solve it, you will get minus 54 by 7. And finally, the I3. I3 is nothing but your I0 also, correct? And that will be delta 3 upon delta. So delta 3 is how much? Minus 112 and delta is 28. So if you see this, it will be minus 4 ampere. So this is actually the answer. We have to find I0 only. So that I0 is actually I3 and the value is minus 4 ampere. So what we understand from this discussion is it doesn't matter whether we have to solve the questions with nodal analysis or we can say we have to use it, we have to use mesh analysis. The method remains same. It doesn't matter which kind of source we are having. So there would be one more video where I will be discussing like if we are using superposition or Thevenin and Norton, then what is the effect of this dependent source? But today we understood if it is mesh and nodal analysis, it hardly matters. The method is going to remain exactly same. So that's it for today. I'll be seeing you in some other video where we can discuss the problems based on superposition and that involve dependent sources. So God bless you all and thank you.